Welcome everyone. It's great to be here. And as Sophia said, I'm going to be talking about synthesizing and presenting results using other methods. So what I want to do is just first of all present a framework for synthesis. Now, for any of you who may have attended the first presentation in the series, you will have seen this. And there's essentially three kind of broad steps. There's the protocol stage where you set up your PICO questions, specifying your intervention groups, comparisons, outcome groups, and any other groups. Then you summarize the included studies and you prepare for synthesis. So that involves summarizing characteristics of each study, determining which studies are eligible for each comparison, determining what data are available for synthesis, and determining if modification to the planned comparisons or outcomes is needed, and synthesizing the characteristics of the studies contributed to each comparison. And then the final step is the synthesis step. I should say that step 2 is covered in chapter 9 of the Cochrane Handbook. The final step is the synthesis, and that's where you perform a statistical synthesis or provide a structured reporting of the effects, and you interpret and describe the results. And that is captured in chapters 10 and 12 of the Cochrane Handbook. So way back in May when this series started, Sue Brennan from Monash University began with defining a review question, applying the framework for synthesis. So she covered off those first two steps. And then subsequent to that, there has been a series of presentations or webinars that have kind of gone through the different synthesis options, including meta-analysis, exploring heterogeneity, and then some complexities around analysing other outcomes and study designs. And I'm lucky last to present in this series. And I'm presenting on the material which is contained within chapter 12 of the handbook, which is what you do when you can't do meta-analysis. So it's synthesizing and presenting results when meta-analysis is not possible. Okay, I'm just going to begin with a quick poll to get you thinking. And here we have fictional data. This is looking at the effects of pedometers versus no or minimal interventions on BMI. We've got a set of studies here, and obviously lower BMI shows that pedometers are favorable, and a higher BMI indicates that the alternative intervention that's been compared to is favorable. So what I want you to do is we're going to launch a poll, and the poll is, are pedometers effective for reducing BMI? So hopefully you should see that now. Okay, I think we can kind of in that poll now and share the results there. So hopefully you can see that. So what we have here is you can see that there's quite a range of responses to this question. Some of you, 11% have indicated yes, they are effective. 37% have said probably, 29% have said no, and 23% have said don't know. So as soon as we don't have a meta-analysis, you can see that you start to get quite potentially a different spread of findings. Okay, so thank you for that. What I'm going to do now is move on to the second poll. And the second poll is, how did you come to your conclusion? So Oliver has launched that. So you should have that now. The response options now are that you looked at the direction of the effects, you looked at the direction of the effects and their confidence intervals, you did something different to that, or you didn't know what to do. Okay, we've got most of you, the majority at least, participating, so I think we can share the results here. And the results there, again, you can see there's a bit more of a spread. Most of you are looking at the direction of the effects and their confidence intervals. Some of you are just looking at the direction of the effects, and some of you didn't know what to do. So again, it's quite tricky sometimes to know what to do if we make the decision not to do a meta-analysis. Okay, so let's move on. I'm going to this is an overview of the available methods for summary and synthesis that are presented in chapter 9 of the handbook. And I'm really going to hinge this workshop or webinar today around this. So I'm going to keep coming back to this to talk it through. So what we have on the right-hand side is the preferred statistical methods. So these are meta-analysis, network meta-analysis, subgroup analysis, and meta-regression. So you've had these kind of webinars have kind of focused on at least the pairwise meta-analysis and the subgroup meta-regression topics. And there's lots of benefits to meta-analysis that if you attended those, you will have seen. But actually, it's not always the case that we're able to use meta-analysis, and there are a set of acceptable statistical synthesis methods that we might use when we can't do a meta-analysis, which we're going to focus on today. And always we can use text, tabular, and structured summary of the evidence should alongside any statistical synthesis method we use. In fact, we should always do that. And then also there's a set of plots that we can use. You're all very familiar with the forest plot, but there are other plots that you might use that kind of more naturally accompany the other synthesis methods. And we're going to talk through some of those today too. Okay, so what are the reasons for not undertaking a meta-analysis? Well, there are a set of legitimate reasons. Sometimes you can have limited evidence for a pre-specified comparison, so it can be a very new area, for example, and there might only be one or no studies that actually examine the effects of a particular intervention. It could be that there's incompletely reported outcomes or effects estimates. It could be that there are different effect measures across studies. So some studies might dichotomize time to event data, others don't, and that might lead to the reporting of hazard ratios in some studies and risk ratios in other studies, which complicates things. And then, of course, there's bias in the evidence where you might have missing studies, outcomes, or bias methodological features within those studies that can bias the effect estimates. Commonly cited reasons where meta-analysis should still be considered. So you'll often read in systematic reviews the comment that there was clinical or methodological diversity. If that's the scenario, then what you can potentially do is consider modifying comparisons with the rationale if you weren't expecting the diversity that you ultimately do come across. And people will say, oh, there's too much statistical heterogeneity. Well, one way to deal with that is to attempt to actually try to explain it. And also sometimes we can do something by calculating something known as prediction intervals, which can describe the intervention effects across the studies. Arguments against using meta-analysis because of too much diversity equally apply to the other synthesis methods. So if it's the case that you say you can't do a meta-analysis because of clinical and methodological diversity or statistical heterogeneity, then don't turn to the statistical methods that we are going to talk about today, because there's a contradiction, I guess, in the argument, or it's an illogical argument there. So really what I'm going to talk about is the synthesis methods are really to deal with incompletely reported outcomes or effect estimates and different effect measures across studies. The issues of bias in the evidence are, the same when you're using other synthesis methods as meta-analysis. And of course, if you just don't have the evidence, then you can't do any type of synthesis. So we're going to go forth and really think about the synthesis methods that cover off point 2 and 3. So let's just begin with something very simple here. We've got a single study and outcome. Now, there might be an example of reporting. The intervention had a small effect on anxiety levels compared with the control. They present an effect estimate and a confidence interval and a scale and an interpretation around that anxiety. From that, we have the information we need to do a meta-analysis. So you might recall that the core ingredients you really need to do a meta-analysis are an estimate of the intervention effect and some estimate of the precision, which we often call the variance of the estimate. So if we have that scenario, great, we could include the study in a meta-analysis. Sometimes you'll get, though, less complete reporting. For example, here we might have someone report the intervention reduced anxiety levels by minus 0.52 compared with the control. We now have no information about how certain we are about that effect estimate. And when I'm talking about certain, certainty, I'm talking about statistical certainty, not the certainty that is often talked about in terms of grading the evidence. If we only have that information, we know we have an estimate of the magnitude of the intervention effect. We can clearly calculate that. We can clearly know what the direction of the effect is, but we can't include that result within a meta-analysis. We might have, again, less complete reporting. The intervention reduced anxiety levels, but was not statistically significant. Now we know the direction of the effect. We don't know anything about the magnitude. We know something about the statistical significance, but we don't have the information to include this study in the meta-analysis. And then finally, we can have very incomplete reporting where it might just be written in the paper, the intervention reduced anxiety levels. So we know something about the direction, but we don't have the information to include this study in a meta-analysis. Then things get more complicated when you start to look across studies. So now let's think about multiple studies for a single outcome. We might have this variation in what's reported. And also the effect measures could vary. So we could have a mix of odds ratios and mean differences, for example, if it's the case the outcome is being categorized or dichotomized. So in these circumstances, consideration might be given to using other synthesis methods beyond meta-analysis. Okay, I'm going to begin with structured summaries. As I said, so coming back to our overview of the available methods, structured summaries are always an important thing to do in any review. They're particularly important to do when you're not doing a meta-analysis. So what we do when we do a structured summary, one way to kind of think about this is to consider ordering the studies in the text, tables, and figures to increase the prominence of the most relevant and trustworthy evidence. Options include, for example, you can order by the certainty of the evidence of the individual studies, risk of bias, study size, or other study design characteristics. Characteristics that determine how directly a study addresses the review question, for example, relevance and the validity of the outcome measures and time of the publication. This is a worked example I'm going to keep coming back to, and this is actually presented in chapter 12 of the Cochrane Handbook. So I won't talk to all the detail today, but that resource is there for you to go and have a look at. So this is from a Cochrane review, but we've kind of altered the data within it to kind of demonstrate the different methods. And this was a review looking at the effects of midwife-led continuity models of care versus other models of care on maternal satisfaction during labour and the birth period. So what we have here, you can see, is we have the results ordered by the risk of bias to increase prominence of the most trustworthy evidence. So here a decision's been made to not meta-analyse, and we've got the studies that are judged to be at a low risk of bias sitting at the top of the table, those with some concerns in the middle of the table, and then those at a high risk of bias at the bottom of the table. And then something that's also incredibly helpful to do is to calculate a standardized effect measure because this aids interpretation. It's particularly important not to just present, for example, the summary statistics that might be quite different across the various studies. It makes it very difficult for people who users of reviews to actually understand what the effects of the interventions are. So if it's possible to calculate a standardized effect measure, then that really is helpful for aiding interpretation. And what's been done here is an odds ratio has been calculated. I'm not going into details about how that's done, but there are formulas that are presented in chapter 10 of the Cochrane Handbook that allow you to convert, for example, standardized mean differences to odds ratios. And so in doing so, you get a sense of the size of the intervention effects on the same scale across the studies. Also incredibly helpful is the forest plot. Even if you make the decision for whatever reason not to pull the estimates presenting the studies. In this case, they're stratified by the risk of bias judgments, allows people to kind of have an understanding of what the kind of magnitude of intervention effects are. So how might you write this up? Well, at the beginning, you might say something like, the table and figure present results for the 12 included studies that reported a measure of maternal satisfaction with care, hereafter referred to as satisfaction. And then the next bit of text basically says, here we summarize results from the studies providing high or moderate certainty evidence based on grade for which results from a valid measure of global satisfaction were available. So in doing so, you're very clear to say what you are going to talk about, because when you have a set of individual studies, it's very easy just to potentially selectively kind of pull out interesting results as you report it. But if you have a process for kind of structuring your summary and determining what results you're actually going to report on, that is much more kind of transparent to a reader around why you have kind of focused in on the results that you have. Then there's a set of text here that reports the results for the studies that meet that criteria. And then there's a kind of concluding bit of text that says for the remaining 10 studies, reported specific aspects of satisfaction, used tools with little or no evidence of validity and reliability, or provided low or very low certainty evidence. So there's not a focus on the results of those studies because in your structured summary, you've determined you're not going to kind of highlight those studies in the summary. So in any systematic review, we're aiming to make the best use of available research, fairly represent the results, and be transparent about the methods used, interpreting results appropriately, and acknowledging any limitations in the methods. Structured summaries really help with this, but it's more challenging to achieve these aims without a synthesis, and especially without a meta-analysis. And I just want to turn to the literature for an example. This is an example looking at the effects of long-term mental health prevention interventions for youth. Here they've been very good at documenting all the effect estimates. They actually, in this particular study and this review, provide no synthesis methods. They tabulate the individual study results. And for the outcome depression as shown here, they calculate these standardized effects, and within the text, they report the range of effects. Then they make this conclusion: the interventions reviewed were as effective or more effective at improving mental health symptoms than the respective controls. But there's a complete black box in how they go from the information they present in the table to the conclusion. So what synthesis method are they using to go from that table to the conclusion? And this example I present here is not a one-off. You can pick up many systematic reviews and you will find exactly this happens. What I really want to push the point today is we want to get away from this. Whatever you do, you need to be very explicit about how you go from your results to your overall kind of interpretation of those results. It's really fundamental for users to be able to understand what you've done and whether they kind of trust the process that you've done. Okay, acceptable synthesis methods and accompanying visual displays. Okay, coming back to our overview diagram, I've talked about the preferred statistical methods give us lots of benefits, but now we're going to talk through some of the acceptable synthesis methods. So similar to a meta-analysis of effect estimates, the acceptable synthesis methods involve these two primary steps. The first is that you need a standardized summary statistic to calculate for each study that quantifies somehow the impact of the intervention. And then there's some mathematical formula that we use to combine those summary statistics across the studies. In meta-analysis, we're very familiar with this idea. In step one, we might calculate risk ratios, odds ratios, mean differences, standardized mean differences. Step two, we use this kind of weighted average formula to bring together those effect estimates. Things are a little bit different when we look at the other synthesis methods, which I'll talk through. So unlike meta-analysis effect estimates, the acceptable synthesis methods differ in the data they require, the questions they address, and the conclusions and recommendations that can be drawn. So here is a table of the different methods and the information that you need to be able to use those methods. And I'm going to talk through in more detail about that information. So let's begin with summarizing effect estimates. So what this question is addressed by using this method is what is the range and distribution of the observed effects. So we can use this method to synthesize when it's difficult to undertake a meta-analysis. And this means that we're missing information such as the variance of the effects or the precision. So standard errors or confidence intervals, or it might be, it might be that there are unit of analysis errors and we might not be able to correct the standard errors for those, for example. What it provides us with is information on the magnitude and the range of the observed effects, and the effects that we calculate are summarized using descriptive statistics such as medians, interquartile range, and the range. So you'll be very familiar with those kind of descriptive statistics that are commonly used. So I'm going to keep coming back to this table here. Again, this is really a subset of the results that are presented in chapter 12 for the worked example. But the required data, as I said, to use this method is the effect estimates without measures of precision. And let's just talk through the columns here. The first one on the left hand, we have the study ID. We've got these grey rows which indicate what type of outcome we have. We have the outcome scale, the outcome here. In this case, all the outcomes have been standardized so that a higher, having an event means you have more satisfied, or if it's a continuous outcome, a higher value means greater satisfaction. Here we've got the risk of bias judgment. And here we've created different scenarios, again, kind of modifying the data to just illustrate these methods. And what you can see here is in this particular scenario, we have the means, we have the data that's available so for some studies, we've got means and standard deviations. Other studies, we just have an odds ratio reported. So here, an odds ratio of 0.9. Here we've got an odds ratio and a p-value. But what you can see here is that there's kind of inconsistency in the level of detail that's reported for each study. So it was the case that a measure of variance was not reported and couldn't be calculated for 10 of the studies. And so one way to deal with this is to potentially use this synthesis method. The first thing we would have to do is calculate standardized estimates. And what we've done here is to calculate odds ratios. And again, the details of how to do this are outlined within the handbook. And then all we need to do is to calculate the summary descriptive statistics of those effect estimates. So it could be the median odds ratio and the interquartile range. How this might be written up, you might write something like the median odds ratio of satisfaction was 1.32 for midwife-led models of care compared with other models, and the interquartile range of those effect estimates range from 1.02 to 1.53, and that's calculated from 15 studies. Now, the accompanying visual presentation when you're using descriptive statistics is naturally the box and whisker plot here. And just to kind of really, there are kind of 5 key data points on it that are presented on a box and whisker plot. Box at the bottom is the 25th percentile. The middle line here is the 50th percentile, and the top line is the 75th percentile. And then you can also do things like look at the studies that were judged to be at a low risk of bias compared with those at a high risk of bias, and look to see whether those distributions are different. So what it looks like when you look here, it looks to be the case that the odds ratios tend to be a bit higher in studies that have some concerns or high risk of bias. Another natural pairing for this type of method, another visual display is a bubble plot. This is particularly helpful where you only have a smaller number of effect estimates. So here again, we've got all the odds ratios for the 15 studies. Those at a low risk of bias, some concerns, and high risk of bias are indicated by the color of the dot. And then we've also split this by the particular type model of care, so whether it's team-based or caseload. And what you can see here is it doesn't really look like there's a lot of difference between the effect estimates. So it might be the case that the particular model of care doesn't look to kind of explain variation in the effect estimates, just as a kind of visual impression. I will skip this one because I realize that time is rapidly going. So the limitations of this method really is essentially that it doesn't account for the differences in the relative size of the studies. So small studies contribute as much information as large studies. So a study of 10 participants essentially contributes as much information as a study of 10,000 participants. Okay, combining p-values. So this can be used to address the question, is there evidence that there's an effect in at least one study? And it can be used to synthesize results when we have even more incomplete reporting of the effect estimates. So all we need to use this method is no or minimal information beyond p-values and the direction of effect. So we need the p-value and the direction of effect, and we can use this method. It means we can combine results of non-parametric analyses with parametric analyses. It means we can combine results of different types of outcomes and different types of statistical tests. So some studies have used a normal test versus other studies using a t-test. We can combine those together using this method. Outcomes are different across the studies. We can use it. So for example, where you might have serious side effects, or you might have death. You've got quite different outcomes, but you might be able to combine them together using this method. Okay, so the required data is the p-value and the direction of effect. And what we have here, again, minimal reporting of the data and statistical tests. So if we look across here, again, this is fictional data that we've created. We've got this particular study here where we know the direction of effect, we know the p-value. Here we've got more information. Down here we've got no information essentially at all. So we've got, quite incomplete and quite varied information reported across the studies. So 11 of the 15 studies provide a precise p-value and a direction of effect, and 2 report a p-value less than a threshold. So we're able to meta-analyze those using this method. Again, the first step is to actually calculate a standardized metric. And I'm not going to go into too much detail about this, but we have to create a one-sided p-value, and we have to correct the direction of that p-value, as we do sometimes when we're reversing the direction of a scale. We do that, we calculate the standardized metric, and then we essentially combine the p-values. The method that's described in the handbook is the Fisher's method for meta-analyzing p-values from K statistical studies. That's the number of studies. And what we do is we just calculate this observed test statistic, which is just really summing up the p-values across the studies, multiplying that by -2, and then we compare that to the chi-squared distribution. And if it's the case that that p-value is very small, then that provides evidence that there's an effect in at least one study. How might you write that up? Well, you might write it up by saying there was strong evidence of the benefit of midwife-led models of care in at least one study. And the accompanying plot here, which I won't spend a lot of time talking about, is something known as an albatross plot for obvious reasons. And this allows us approximate examination of what the underlying intervention effects are for studies that just report the p-values, direction, and sample size. So we just need that information, and we can get a sense of what the size of the effect estimates are through the kind of algebraic relationship. So the contours there reflect the standardized mean difference. So in this case, I think this is a standardized mean difference of 0.5, and each point estimate reflects the study result. And the location of the points relative to the standardized mean difference contours indicates their likely size. So this point here is quite close to 0.5. These ones here sit somewhere between 0.1 and 0.25. So even with very limited reporting in the studies, there are statistical techniques for us to try and get a sense of what the size of the intervention effects might be. So how might we write that up? Well, we might continue and say estimated standardized mean differences for 5 of the outcomes were small, ranging from -0.13 to 0.45. I'm going to skip this example, but we can always come back to it if we have time. The limitations of combining p-values is it provides no information on the magnitude of the effects. It does not distinguish between evidence from large studies with small effects and small studies with large effects. It's difficult to interpret when statistically significant, so the null hypothesis can be rejected on the basis of an effect in just one study. When combining few small studies, a non-statistically significant test should not be interpreted as evidence of no effect in all studies. And that's for kind of similar reasons that we have when we apply any statistical test. Okay, now we're getting to the kind of bottom of the basket, I guess, and we're now just going to look at vote counting based on the direction of effect. So this is the last acceptable synthesis method that we describe in chapter 12. So what does this synthesis method address? Well, it addresses the question of, is there any evidence of an effect? And it can be used to synthesize results when only the direction of effect is reported, or there is inconsistency in the effect measures or the data reported across studies. And for each study, the effect is categorized as either beneficial or harmful just based on the direction of effect. Statistical significance is not considered in this. I will come back to that. And what we can do is we can apply a sign test to test if there's any evidence of an effect, which is equivalent to testing if the true proportion of effects favoring the intervention or favoring the comparator is equal to 0.5. So the required data, we just need direction of effect. So we need minimal reporting to be able to use this method. And that minimal reporting means we're going to be able to include generally most studies within this synthesis method. And it may be a much larger number of studies than can be included in the meta-analysis. So here we have the available data again, and our standardized metric now. And so the minimal reporting of data and type of effect measures varies across the studies. As I said, 12 of the 15 reported direction of effect, 3 didn't. And our standardized metric here is essentially a 1 or a 0, 1 indicating the direction is beneficial to the intervention, 0 indicating the opposite. And as I said, statistical significance is not considered. So here we have satisfaction being higher in the midwife-led models of care compared with the alternative models. And so we have a value of 1 here. In this case here, satisfaction is actually lower in the midwife models of care group. And so this study, the standardized metric is 0. So how would this be written up? Well, here we would say there was evidence that midwife-led models of care had an effect on satisfaction with 10 of 12 studies favoring the intervention. That's what happens when you go through and calculate that. We can also calculate a proportion of studies that are favorable or equivalently a percentage, and we can calculate a confidence interval for that and a p-value. So here, when we look at this, it looks to be the case that midwife-led models of care has an effect on satisfaction. So what's the accompanying visual display here? Well, this is the harvest plot. And what you can see here is we have each of these bars represents a study or an effect estimate. And this is denoted by alphabet characters. The bars are categorized based on their effects. So those where the intervention is favorable and those where the alternative intervention is favorable. And we can do things with the height and shading to depict characteristics of the studies. So in this example, what we have is height depicting the overall risk of bias judgment. And what we've got is tall bars indicating low risk of bias, medium indicating some concerns, and short bars indicating high risk of bias. The reason for that kind of ordering is because visually those studies then get much more prominence. And in this case, the shading depicts the model of care. But, there are obviously lots of different factors that you could use to denote different characteristics of the data. This is another example where actually here we've got multiple outcomes, and we've got a series of harvest plots that are essentially combined in this matrix to display the vote counting results. In this case, we've got different outcomes, but it could also be for different comparisons. And And this comes from a Cochrane review that was looking at air pollution. Again, you probably can't see this, but what's denoted in these bars here is the particular study design. So I think there's a control before after study and interrupted time series studies. So the limitations of this method is that it provides no information on the magnitude of effects. So equal importance is given to a risk difference of 5% and 50%. And obviously that's not very ideal because for clinical decision making, these could have very different implications. It doesn't account for differences in the relative size of the studies. It's less powerful than the methods used to combine p-values, and it's often confused with the unacceptable forms of vote counting. And that is when statistical significance is used to determine the number of positive and the number of negative studies, or when there are kind of subjective decisions used to define positive and negative studies. So let's just look a little bit further about vote counting based on statistical significance, because it's a very common practice. Essentially what happens is you create two stacks of papers. Stack one shows statistically significant studies that show statistically significant benefit from the intervention. Stack two is all other studies. If it's the case stack one is higher, you conclude the intervention is beneficial. Otherwise, you conclude there is no effect. So what is the issue with doing that? Well, we don't recommend using that method. And the reason is that small studies just often have insufficient power to even detect small effects. And so they're always counted as not showing benefit. And so as the number of studies and participants increases, the power of this kind of conventional vote counting method tends to zero. So you will never be able to find evidence of an effect, even when one does exist. Regardless of the specific formulation, when based on statistical significance, all vote counting methods have serious limitations and can lead to the wrong conclusion. The thing is, though, that it's actually a very commonly used method, and people are not explicit to say that they have used that method. So you need to be very careful in your reviews not to ideally use the method. Well, you shouldn't be using the method, but it's okay to do the vote counting based on the direction of effect, not considering statistical significance. Okay, so what to include in the protocol? Provide details of the planned tabular structure for displaying results of individual studies. Provide details of other synthesis and visual display methods that might be used. This is a little bit hard, often looking when you're writing a protocol for a review, to kind of think about all the scenarios and what you need to need to think about pre-specifying if things don't work out the way you planned. The problem is that we see in a lot of reviews where meta-analysis can't be done, reviews tend to kind of fall off a cliff, and you just end up with this kind of, reporting of results. And as a reader, it's very difficult to know which of those results has been, what's the rationale for certain results being kind of highlighted in the text of the review. So it's good to kind of think ahead as to what you might do if you're not able to do a meta-analysis. Some take-home messages. Other synthesis methods may be needed where there's incompletely reported data in the primary studies. These methods differ in the completeness of the data that they require, the hypotheses they address, and the conclusions that can be drawn from their findings. So you can see that when I talk through all the limitations of those methods, they are giving us nothing as helpful as what we get from meta-analysis, but they might give us a signal about the effect of, about whether an intervention might be potentially useful. Tabulation and visual display of results should always be presented alongside any synthesis, and synthesis methods that involve vote counting based on statistical significance have serious limitations and are unacceptable. Okay, so I finished. Hopefully, I should say here, I'd like to acknowledge Sue Brennan, who co-wrote Chapter 12 with me and really was instrumental in kind of helping to create the worked example. So I'm going to end there. I've got plenty of time for questions. So
Thank you very much, Joe. This was amazing. A lot of information, which was very insightful. Thank you very much. So, yes, we have a couple of questions from our audience. Maybe we can go through this together. So, okay, we have a question which says that if the review falls under clinical and methodological diversity, shouldn't we attempt synthesis without meta-analysis approach?
I think the issue is when people say, if people have kind of made the argument that they're not doing a meta-analysis because of that, and then they turn around and use other synthesis methods, there's kind of a contradiction. So, because you're still, when you people will often say, you'll see these reviews and they'll say, we couldn't bring together the data because there was too much diversity, clinical diversity. And then they'll say the conclusion will be the particular intervention was effective. Well, how do you get to that point if you weren't prepared to synthesize? And so you've got to be very careful about that argument. If you're saying you can't meta-analyze, well, you shouldn't be kind of bringing the data together at all, because of that same argument.
Exactly, totally agree. Thank you. Okay, then we have a couple of questions about calculations. And so if the standardized mean difference is not available in all studies in a review, is then a structured summary sufficient? Or?
Yeah, so I think the structured summary is always very helpful. It is particularly helpful in reviews. It's particularly helpful when people don't do meta-analyses. So maybe just to backtrack a bit, that Miranda Compston, some of you might know of her. She did a PhD with myself and Sue Brennan, James Thomas a few years ago, and what we really found. So we were looking at what kind of methods, statistical synthesis methods people were using when they didn't do meta-analysis. What we found was it was actually really hard to actually identify the questions that people were answering when they didn't have a meta-analysis, because a meta-analysis actually provides the structure, it provides the comparison, it provides the outcome, it provides the subgroups, for example. So it actually is all within that you understand the question. When people don't do a meta-analysis, suddenly as a user, it's often very hard to work out what question they're trying to answer. Structured summaries can help with that, because you can still essentially set up the comparison in tables with the standardized statistics if you're able to, but you can at least set up the kind of comparisons in those tables and make it clear what comparison and what question you're trying to answer. Not sure if that's really addressed all of that question.
Well, I think that's yes. Thank you. So have another one. So if the studies don't have a control but report before and after intervention at different time points, can we still do synthesis without meta-analysis using the summary of effects?
I think that's exactly the same question
Yes.
as
Yeah.
it's the same question as what you do in
Exactly.
meta-analysis. So it's not actually any different.
Yeah.
If you're going to include before or after studies, that's a different decision to what synthesis method you'll use.
Yeah. Thank you. Okay, so we have a couple of questions about the method about combining p-values. So why would a research question be around knowing if there is an effect in at least one study? What about the rest of the
Yeah.
studies?
Yeah, I know. Look, it's a method, right? It's a method that what you get out of it, is kind of quite limited. And I acknowledge that. I'm not trying to say that, ideally we don't want to use these methods. These are acceptable methods. They're not preferred methods. But yeah, I mean, when you calculate for each individual study, you calculate a p-value, that's a kind of random variable. So when you combine those p-values, you are just addressing this question of, is the evidence that it's kind of telling you whether there might be a signal that the intervention might be effective. I mean, the example that I didn't present about homeopathy, if we have time, I can always go back to that to show that, because I think it might kind of be helpful for showing what it can do. But let's continue with the questions, and if we've got time, I can potentially go back.
Okay, thank you.
There's a lot of questions, so that's
Yes, that's very interesting. So we have another one for the vote counting method. So if there are more examples of what can be counted if no p-values are that are statistically significant or not. So do we need, for example, to set a threshold of such as passing satisfaction higher than an X value?
you can actually vote count based on that, but the problem with doing that is often when you're vote counting, you've got different effect measures being used across the studies. So that becomes more tricky to do. So you might have, say, in one study a risk ratio, another study a standardized mean difference. So that's what limits that. That's what's often kind of, you're just kind of saying, is the evidence the intervention is beneficial or harmful?
Mm-hmm. Yeah.
Yeah.
Thank you. Okay, then we have a question about the midwifery continuity of care example. So in that example, where authors created the forest plots without meta-analysis, why the meta-analysis was not attempted, given that authors managed to calculate all the ingredients of
Yeah.
the meta-analysis?
Yeah. Look, it's an interesting question. When we began this work, which is a very long time ago, um, uh, we were looking at these different synthesis methods, and
Mm-hmm.
there was this, it's a very good review, I should say. So, but satisfaction with care was one of the, I think, a secondary outcome in the review. And what they had done was within each study, they had pulled out all the measures of satisfaction with care, and they had presented the available summary statistics. So they hadn't attempted to actually kind of calculate a standardized effect. And so in my downtime, I took on that task. And as it turned out, there was a way to really kind of actually bring that together. So I think, I mean, you'll know as authors of reviews, it's very time consuming. The more outcomes you have, some particular outcomes where you're looking at kind of, satisfaction, anxiety, depression, studies often report multiple of those outcomes. And so, it's a lot of work to be done to kind of standardize those effect estimates and bring them together. So I think probably for them, I don't know the reason why they didn't do. Well, one of the reasons they actually felt too, I think, was that the measures were quite different. And because some of the measures are at different times during pregnancy and post-pregnancy, some of the kind of measures of satisfaction of care, when you look at what constitutes the items within those measures, are quite different. So I think they felt there were other kind of reasons why they might not be happy to have brought them together. But it's just an example we've kind of worked with.
Thank you. And we have one more question about the protocol. So at the protocol states we might not know that meta-analysis is not possible with the data found, and therefore not include in the protocol any of the methods that are being that we discussed today. So is it acceptable to say that in the review manuscript that we didn't do a meta-analysis because of X and Y reasons, rather than we used the Z methods to synthesize and present results, and list this and describe accordingly?
We used um
Yes, I guess the question is more like we don't know what the protocol. When we write the protocol, we don't really know what's we will
yeah,
control.
you don't know what you're going to end up with. Yeah, I completely agree with that. Um I guess there's always this kind of issue, isn't there, that so you can always set up a kind of hierarchy of what you'll do. I guess that's one thing you can do. So even although you might not know the particular method you'll end up using, you can say, well, if it's the case that we have very incomplete reporting, we'll use vote counting based on the direction of effect. If we have more complete reporting, we'll use summary statistics to describe effect estimates. I guess what I'm saying is think about this at the outset. Think about how you will structure your tables, because we have very good evidence from the kind of research we've done that when people don't do that, these reviews just kind of end up in, they just can end up very messy. And so while you don't have to, I guess, have chapter and verse in your protocol, you should at least think about what you will do if you can't meta-analyze. It's often the case too that you might be able to meta-analyze a small fraction of studies out of the total number of studies. So what will you do then? You just going to rely on those few studies? Are you going to potentially say something about the direction of the effect of the total body of evidence that you have? So I think it pays to think about this, and the best place to do that is really to say something about that in your protocol.
Okay, I agree. Thank you. Okay, we have one more question. So, okay, thanks, John. That was very helpful. And would you mind answering the first full question that's he posed, please? Given.
Well, you mean as to what method I would use, or was there an effect? There was, I haven't got the slide here actually, but there is a small effect, if I meta-analyze, and of course that's what I would do in this situation. Whether it's an important effect, I think it's uncertain because the upper limit of the confidence interval is very close to the null value of 0. So, if you were grading it, you might say there was uncertainty.
Okay.
I don't know if that's what you were wanting, the specific answer to that question.
Okay, thank you. And I think we have time for one or two more. So in vote counting, there is an effect direction plot with triangles where their size determines the study size. Is that an acceptable visual plot?
Yeah, look, the effect direction plot is, I think that, so there's two versions of it. The original version of the plot, I think, may have been based on statistical significance, which is why we didn't include it as, why we do we include it in the handbook? I can't recall now. We might say something about it in the handbook. But then I think Hilary Thompson, they published another paper in research synthesis methods where I think they may have redone it not based on statistical significance. So just be careful that you're not kind of, if you use it, you're not basing it on statistical significance.
Mm-hmm. Thank you. And one more about vote counting. So, can we combine methods, vote counting methods for different outcome measures with all? I'm sorry, with all studies, with SMTs, and still comment on statistics or address the direction of effects?
Yeah, so completely. So I guess what I'm always saying is when you use these other synthesis methods, because the big problem with them all, aside from where you're kind of just, using descriptive statistics to describe the size of the effects, if you use vote counting or combining p-values, you're not getting any information on the magnitude of effect. So you always need to accompany, if you're using that statistical method, you should always accompany it with tables where the available effect estimates are reported and have some description of those. And again, that kind of where that structured summary becomes very important, because you can say why you might be describing particular results. So the results that are more trustworthy, for example, which is very similar to what we actually do in a meta-analysis. We'll set up at the outset, we might say, we're only going to include in our meta-analysis studies that are at a low risk of bias and some concerns, for example. It's the same idea here. So it's not actually conceptually different.
Okay, thank you. And a last one, a more generic one. So, as a researcher, should we frame a question or use inclusion or exclusion criteria in a way that always ends up in what's analyzing rather than not?
I'm not quite sure what you mean there, that you would just kind of like you'd only say that, this is for the studies that report results. This is the effect for studies that report results. Is that what you get to?
Yes. Probably.
I wouldn't recommend that.
Yes.
Your inclusion exclusion criteria. Essentially, what you're doing in a review is, you set up your eligibility criteria for each comparison. So in reviews, we're often thinking about setting up eligibility criteria for the review. Essentially, though, you're also setting up the eligibility criteria for each question. Then you have you then are trying to say, well, these studies actually address that particular question. Now, if those studies don't report the results for that particular question, there might be concerns that you have for why that is the case. It could be that, for example, there's reporting biases at play. But you wouldn't change your eligibility criteria.